Okay, welcome to today's video everyone. Evaluate the limit as x approaches infinity of x squared plus 1 over x minus 2 minus x squared plus 1 over x plus 2. Okay, so with these types of questions we have a rational function, and so usually we would divide by the highest power of x on the numerator and denominator, and then we'd use our rule that the limit as x approaches infinity of 1 over x is equal to 0. But as you can see here, the highest power is on the numerator here, and so this will go to infinity, and the highest power in this fraction is also on the numerator, so this will go to infinity. And so we're going to get infinity minus infinity, but we can't really deal with that. This is an indeterminate form. So we need to manipulate this a little bit so that we can get it in a form that we can work with. So let's make a common denominator here. So if we do that, we multiply up, we're going to get x squared plus 1 times x plus 2 minus x squared plus 1 times x minus 2 all over, and here you can see that this will become a difference of two squares, so this will become x squared minus 4. So this is just multiplying those two. Okay, let's go ahead and simplify what we have in the numerator. Okay, so this will become x cubed plus 2x squared plus x plus 2 minus x cubed minus 2x squared plus x and minus 2 all over x squared minus 4. Okay, now we can do a bit of cancelling in the numerator, and this will simplify. So x cubed minus x cubed is 0. We have 2x squared minus 2x squared, so we're going to add them, and we're going to get 4x squared. Then we're going to have x minus x, which will be 0, and we'll have 2 minus 2, so that's going to be 2 plus 2, which is 4, divided by x squared minus 4. Okay, so now we have something that's a bit better to work with. We can divide the numerator and the denominator by the highest power of x, which is, in this case, x squared. So let's do that. Limit as x approaches infinity. Now the highest power of x is x squared, so 4x squared plus 4 over x squared all over x squared minus 4 over x squared. Okay. And the reason we do this is so that now we can split these two fractions up. This will become 4 plus 4 over x squared all over. This will be 1 minus 4 over x squared. And now we use the rule that the limit as x approaches infinity of 1 over x is equal to 0. So if 1 over x goes to 0, then 1 over x squared will definitely go to 0. In fact, it will get to 0 quicker than 1 over x. So we have these x squareds. So this term here will go to 0, and this term here will go to 0. So we're left with 4 plus 0 over 1 minus 0. And then we can clearly see that this is 4. And so this is our final answer. Okay, so the trick with this was we're dealing with rational functions, so we're trying to divide by the highest power of x on the numerator and the denominator. Now when we did this originally, it gave us infinity minus infinity, which doesn't mean anything to us. We can't have that as an answer, and so we needed to do some algebraic manipulation until we could get to something that we could work with, which was around here. And then we can simplify it and get down to 4. Okay, thanks for watching.